Welcome to Study Loop.
For part A, we're showing all the distinct states for an electron in the in shell of hydrogen. So this can go up to L equals 3. When L equals 3, M sub L can go from negative L all the way to L of integer values. So M sub L is equal to 0, plus or minus 1, plus or minus 2, plus or minus 3. M sub S, the spin, since we're dealing with electrons, is going to be plus or minus a half. So when L equals 2, M sub L can be 0, plus or minus 1, plus or minus 2. M sub S is still a half, plus or minus a half. L equals 1, you get 0 and plus or minus 1. L equals 0, you get M sub L equals 0. And again, for both of those, M sub S equals plus or minus 1/2. For B, for an F electron in the in shell, what's the largest possible orbital angular momentum and the greatest positive value of the component of this angular momentum along the z-axis? What's the magnitude of the spin? We're expressing everything in quantities of h bar. Okay, so for the F electron in the N shell, we have n equals 4. Since L goes from 0 to n minus 1, the maximum L value is going to be L is equal to 3. Since n minus 1, the largest value is 3, if n equals 4. The angular momentum, capital L, is equal to the square root of L times L plus 1 for L equals 3. This gives us 3 plus 1, which is 4, times 3, which is 12. So this is equal to the square root of 12 h bar. And that's one of yours, so we can box that in. The z component of the angular momentum, which we can call L sub z, is to M sub L bar. Well, we want the minimum component, maximum M sub L value. And remember, M sub L can go from L equals, or negative L all the way to L. So that's plus or minus 3, plus or minus 2, plus or minus 1, and 0. So the maximum M sub L value is 3. So this is 3 h bar. And then it wants the spin angular momentum, S, which is equal to the square root of M sub S times M sub S times M sub S is a half, so the plus value is so 1/2 plus 1 is 3/2 times 1/2 is 3/4. The square root of 3/4 times h bar. The final part of solution B. Part C has us using the D state of the N shell and wanting all of the values once again. Okay, so for the D state, part C, L is equal to 2. For the angular momentum, capital, which is the square root of L times 1. So there's a square root of h bar. And equals 2, the maximum M sub L now is 2. So therefore L sub z is going to be 2 times h. Part D is conceptual, and it says, what is the largest value of the orbital angular momentum for any F electron in the M shell? So this is, the last part of part C is to find the minimum and maximum angles. Sorry about that. Let's do that real quick. So we'll call one the min, cosine theta equal to L sub z over L. Therefore, theta is equal to cosine of L sub z over L. The value is L sub z is 2 h bar, and L is root 6 h bar, right? So this is 2 over root 6, which is to 35.2 degrees. So we're using the smaller values of L that we found above. Maximum, for the max value, we're using L sub z equals to -2 and then over root 6. So let's go ahead and be explicit. For the maximum is going to be when L sub z is the -2, right? Because it's plus or minus 2. So we can do two over root 6, which is 180 difference. So this gives us 144.7 degrees. And then part D. So now I'm finally moving on to part D. This is actually a conceptual question because it's not possible since L equals 3 for an F, but a maximum value of 2 is possible in the M shell. So let's go ahead and type this out. Max value of 2 in the M shell, but L equals 3 for an F